So these parts here, you notice the ones that are different colors were fully processed, and the ones that are still gray, you know, were being skipped over.
Okay.
So that's kind of the processing of that, you know, base, you know, assembly file. And if we like, I can select this particular part, for example. Oops. Clicked on something here that locked it up. That, not sure what I selected there, but it's not. There it goes. Okay, hide others. So, you know, we can zoom in on just this one part. And so you see it's that green, that indicates that it detected a feature.
Yeah.
And then what's going on in the background in the next step of the process, you know, just to show you what was done in our method pattern here. This shows features that it's detected models. So these are all features that I've detected over time. We got louvers and countersinks and embosses and things like that from different components. So this is a countersink, and then it has that base description of the countersink and the direction that it's going. And then down here, we teach it what the processes are. So I just have step 1, round hole 547. So let's say it's supposed to be some other diameter. You know, you would enter in whatever that diameter is that you want it to cut when it sees that feature.
So in this case, if we had a hole that was modeled in at a certain diameter, but we actually wanted it to be more of a clearance hole, even though it was modeled with a slightly smaller diameter, we can modify that in this at this stage. Yeah.
So any feature or geometry that comes through, we can have it auto manipulate it with this tool. And we can do multiple steps. Like, for example, this one's set to step 1, do a round hole 547. If I had a combination machine, I could say, okay, well, step 2 is going to be a forming tool, and the forming tool that's going to use is this countersink tool. So now it's going to automatically cut a 547 hole, and then it's going to apply a special turret punch that's going to automatically do the countersink. And that'll automatically be done every time it sees that same geometry. So we set this up once, and then every time it sees that same geometry, it automatically applies these rules.
Okay. Now, how is it recognizing those features? Is it using the SolidWorks file in its own design tree and looking at the features that were there, or is it just looking at the geometry and taking its best educated guess?
It's looking at the geometry and then basically measuring that geometry and the profile of it. So if you have 2 engineers that draw countersinks differently, you would have to set this table up with redundancy to when you bring in the first engineer's file and then bring the second engineer's file in, and then you would set both of those geometries up to do the same thing, basically.
Okay. So it would detect the difference there. Okay. That could be, I suppose, good, but also a little bit cumbersome to set up initially, but presumably that would get better if you make repeated parts a lot.